Hello, Fruitport High School chemistry students. Mr. Kovalek here coming at you again with a little bit of a lesson to follow up on our density. So this video is going to be posted Friday and or Monday if you're in the other cohort. And you have worked on as whiteboards with mass and volume, and we should have understood the idea of density. So I wanted to make sure that if you're absent, you got some good information. And if you were there, that you got some hints to get you through to the rest of the thing. Okay, rest of the packet that's due tomorrow. Also test next week. Okay, let me flip the camera around. And so if you did the assignment from our little lab, you should have had a graph that looks something like this with two lines with different slopes. And my graph's not perfect. I don't have a title, and I haven't put in the grams yet and the milliliters. But one of the things you had to do is you had to find the slope. And remember that the reason we find slope is because the slope always means something. And from our discussion, you know that the slope means density if we're comparing mass and volume. Okay, so let's talk about what density is. So here's a little bit of notes that you can write down. So density is a ratio of the mass of an object to the volume of an object. And a lot of times we look at it mathematically in this formula. Density equals mass over volume. And we can use any mass unit. Those include things like pounds and kilograms, but usually our mass unit is going to be in grams. And volume could be pints or gallons or liters, but the most common is milliliters. Remember, that's the same thing as a centimeter cubed. But so the mass units are grams, the volumes are milliliters, and together you have density, grams divided by milliliters. So this are the units for density. Now, sometimes people are a little bit concerned, like, I don't get this. I thought that how can you have 2 units for density? But it's just like speed where you measure something in miles per hour. You can have 2 units for density. Okay, so if we were to find the slope of this red line, we would know the density of this red line. Okay, and so if you wanted some help with that, let me kind of just put this little sticky note here to practice how we get slope. Okay, so slope, remember, is going to be the change in y divided by the change in x. And so if I pick like, if I pick like something close to this spot on the line, and I look that it's, how about if I compare these two dots right here, okay? And I know the line's not right on the dots, but they're pretty close. And so this looks to me like I'm a little bit less than 10. So let's say that's 9, and this spot looks a little bit above 20, so let's say 21. So my change in y would be 21 grams minus 9 grams. And if I do that in the calculator, I would get 12 grams. But I also have to take the same 2 dots and see how much it ran over. Remember, this was our rise. Our change was our going this way. Our change in y is our y's. But to go from this dot to this dot, we're doing our run. And this dot looks a little bit less than 5. So let's say that's 4 milliliters. And this dot looks like it's, I don't know, between 5 and 10. Let's say it's 8. Okay, so 8 milliliters minus 4 milliliters equals 4 milliliters. And if I were to take the grams and divide it by milliliters, 12 divided by 4 equals 3. Now, this is the slope, right? But slope always has units. And the G is still on the top and the ml is still on the bottom. So the units are grams per milliliter. So in this case here, our slope is 3. And if the units are grams per milliliters, and we just learned that grams per milliliters are the units for density, we now know that the slope equals density. Okay, not every graph does slope equal density, but when we have grams on the y-axis and milliliters or volume on the x-axis, our slope will equal density. So you have 2 different lines with 2 different slopes because the two materials you have should have two different densities. Some of those metals might have had very close densities, but we have that. Okay. Now, how do we, let me come back to this real quickly. So this is sometimes a math formula, density equals mass over volume, and we're not going to look at this too much algebraically and mathematically. We're going to let you do that in Physics A with Mr. Roop. And if you've already taken physics, you've done some density work and learned how to do the algebra with it. But we're going to look at it graphically, like we've already done, and we're going to look at it in drawing form. What does that mean? Well, I have two drawings here of molecules like zoomed into a chunk of one metal and a chunk of another metal. And which one do you think would be more dense? Which material? And in this case here, I was trying to show that the dots are closer together here, so it shows that it's more dense. Here, the particles that are being represented by dots are farther apart, and so they're less dense. And it's not a coincidence that I use the same colors here. This slope is steeper with a higher density. The green line is less steep. The slope is less, so it's less dense. And I tried to draw the green particles being less dense than the red particles. Okay? Now, what if I had a bigger piece? What if I had a bigger piece of the red material? Well, I would draw the volume being bigger by showing a bigger square. And if I wanted to put in the dots, all right, I'm trying, and please forgive me for doing this live, I would like to draw the dots about the same distance apart. I'm losing the pattern, aren't I? Right? Sorry about that. But I'm trying to draw the red dots in both particles about the same space apart from one another. And, decent, I guess, maybe not 100% perfect. And I'm trying to show the same spacing out to show they have the same density. Okay? Bigger box than this one, bigger volume. More dots than this one means more mass. But the ratio, remember density is the ratio of mass to volume. How spread out are the dots to each other? That would be the best way to draw density. You're definitely going to have to do that when we do a quiz next week. You're going to have to draw some densities. Okay. So to finish up the video, I want to talk about this packet that is due at the end of next class. You shouldn't finish it before you come, but if there's a few questions that you need to ask before you turn in, you'll have time. So we would like to compare box A and box B here by putting then greater than, less than, or equal than signs on these. And you have to, kind of do mass once, then volume, then density. Now, I have a little typo here. My C for box C kind of here's box A, here's box B. The C kind of got lost, okay? And we just kind of went over that with drawings. This is trying to show the same thing, okay? But then we start to get to some graphs, right? Number 4's got a graph with a bunch of questions about graph number 4. And if you go over on the back where there's a part 6, which that number should have been a 6, I guess, where you have to make a graph. And how are you going to do these? You have to remember that slope means density, density means slope when we have grams and milliliters or grams and centimeters cubed, okay? And then we have a little logic question here, so you can get that one right. And so do the best you can on this, ask some questions, and use what we've learned about density to help us with this process. All right, cheers.